Hello everybody, welcome into another lesson. So today we are going to talk about some properties from algebra, and these properties from algebra are used all the time in geometry proofs. You'll use them all the time, so these are very good to bring up. And we are actually going to do some proofs today. We're going to start doing some proofs, so we'll be ready for that. I will definitely walk you through how to do it, but the first property you may be familiar with is called the addition property. So if A equals B and C equals D, then A plus C is equal to B plus D. Well, yeah, considering A is equal to B and C is equal to D, yes, you would have a true equation. And then similar to it, you have the subtraction property. If A equals B and C equals D, then A minus C equals B minus D. Then you got the multiplication property that if A equals B, then C times A equals C times B. So you're taking some constant C, multiplying it by both A and B on each side, you should get a true statement. You have the division property, which states that if A equals B and C is not equal to 0, then A over C equals B over C. Then we got the distributive property, which everyone should be familiar with also. If you have the quantity of A times the quantity of B plus C, that distributes into AB plus AC. Then the substitution property. If A equals B, then either A or B may be substituted for the other in any equation. When we were doing systems of equations in Algebra 1, when we solve by the substitution method, we use this all the time. We use the substitution property all the time. You'll use it all the time here in geometry also. This one's kind of like a no-brainer. You have the reflexive property, A equals A. Well, duh. I mean, I don't need to say more about that. The symmetric property, if A equals B, then B equals A. Also kind of duh. Then there's the transitive property. If A equals B and B equals C, then A equals C. People tend to get mixed up with reflexive, symmetric, and transitive. So I'm going to give you an easy rhyme for it. You can remember it RST 1, 2, 3. Remember it RST 1, 2, 3. Reflexive has one variable. You're referring to one variable or one item. Symmetric 2, you have two variables or two items. Transitive 3, you have three variables you're talking about. So RST 1, 2, 3. All of these properties you're going to use all the time in geometry from here on out till we're done with the proofs part of the course. All right. So those are handy properties from algebra. Now, what we're going to do, we're going to do a few algebra problems, but it's not going to be normal. We're going to justify each step. All right? So justify each step. All right, so when you're doing proofs in geometry, a lot of teachers will do what's called a two-column proof. You will set up two columns. Some don't do two-column proofs, but very similar to it. But how I was taught, and a lot of teachers still do it, are two-column proofs. On the left side, you have your statements. Then on the right side, you have your reasons. So on the left side, the left column, you have all your statements. The right side, you have your reasons. We're going to do a few algebra problems here. So we have, to start with, statement number 1, 4x minus 5 equals negative 2. So that's your original statement. 4x minus 5 equals negative 2. For reason 1, you could just say given. That was given to you. So statement 1 was just given to you. You could say 1 is given. Now if we do statement 2, we would say 4x equals 3. Well, how did we get to 4x equals 3? Well, we know 4x minus 5 equals negative 2. We had to add a 5 to both sides, right? So reason 2 that 4x equals 3 is the addition property, or you can just abbreviate it add prop. When you're doing proofs, it's okay to do abbreviations, at least the 2-column proofs. If you were doing a thesis paper or a doctorate's paper, you probably wouldn't want to do it this way, but we got to 4x equals 3 by using the addition property. We added 5 to both sides, so that makes sense. And then finally for part 3, we have x equals 3/4. We've arrived at the answer of x equals 3/4. How do we get there? We had to divide both sides by 4. So reason 3 would be the division property. You could abbreviate it div prop. You can abbreviate it div prop. So we got from 4x minus 5 equals negative 2 all the way to x equals 3/4 by using the given information, by using the addition property, then the division property. It's simply basically just explaining what you did to get there. That's really all that is. It's really not that bad. So we did a pseudo kind of proof out of this. We justified it. Now, I'll have a couple more algebraic problems, and then we'll dive into some geometry ones, which is what you really came for. Okay. We have statement 1 here. This one is 3a over 2 equals 6 over 5. So we were just given 3a over 2 equals 6 over 5. Well, this reason 1, again, this was given to you. So reason 1, this was given, okay? Now for number 2, the next statement is we simply have 3a equals 12/5. So 3a equals 12/5 is statement 2. Well, how do we get from here to here? Well, you had to multiply both sides by 2, right? So for reason 2, this would be the multiplication property, which I would just abbreviate it like you see here. The mult prop. That denotes the multiplication property, okay? And then, let's go to statement 3. Statement 3 would be a equals 4/5. So a equals 4/5. Well, how did we get from here to here? Well, you had to divide both sides by 3, right? So reason 3 is going to be the division property. So we got from the original statement here all the way to our answer by using the given information, then using the multiplication property, then using the division property. It's just simply listing the steps you took. With these algebra ones, they really aren't that bad. The early geometry ones we're going to do really aren't that bad either, but doing a geometry proof is a little bit different than justifying these algebra ones, but it's sort of similar. Alright, last one here. First statement, we have z plus 7 all over 3 is equal to negative 11. Okay, so the first statement is z plus 7 all over 3 equals negative 11. Well, the reason is that was given to you. So reason 1, that's the given information. Okay, now statement 2 is that z plus 7 equals negative 33. Well, how did we get there from this to this? We had to multiply both sides by 3, right? So reason 2 is going to be the multiplication property. So got the multiplication property. Now the final statement is z equals negative 40. So how do we get from here to here? Well, you had to subtract 7 from both sides, right? So reason 3 is going to be the subtraction property. I abbreviate subtraction, SUBTR, then prop. The reason I spell it out a bit more is because notice then if you were using the substitution property, it would look similar. That's why you don't want to just say SUB. You want to spell it out just a little bit. Now substitution would be SUBST. That's how you'd abbreviate that. But these are basic algebra proofs from what you can see. It's really not that bad. Time to do our very first geometry proof. I know everyone's ready for this, and the ones we do today aren't going to be that bad at all. Okay. Let me draw some angles here. Now, when dealing with geometry proofs, it often helps to have a diagram to refer to. Okay. We have points A, points B, point C, then we have point D down here. They all come together at the vertex O. These are angles 1, 2, and 3. Angles 1, 2, and 3. Okay. So there's our nice diagram. So let's see. Given angle AOD as shown. So we've been given angle AOD as shown right here. We need to prove what they want us to prove is that the measure of angle AOD equals the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Okay, so we are tasked with proving that the measure of angle AOD equals the sum of the measures of angle 1, 2, and 3. So whenever you're being asked to do a proof in geometry, you're always going to have a given and a prove. And usually you'll see a diagram. If you don't see a diagram, it would certainly be beneficial to you to make one. Pictures can go a long way when doing proofs. Okay, let's set up our columns here. I probably don't need that much space, but I'd rather be safe. I want you to be able to see what it is I'm doing here. Okay, so again, like when we were doing the algebra problems, we have the statements and then we have the reasons. So that part stayed the same. Okay. Now, we could almost go ahead and prove this right away by the segment addition property, but humor me for a second. All they gave you was a diagram. They didn't give you any other statements. So let's start with something like statement 1. You have the measure of angle AOD is equal to the measure of angle AOC plus the measure of angle 3. So we have the measure of angle AOD is equal to the measure of angle AOC plus the measure of angle 3. By looking at the diagram here, we can say that's the angle addition postulate, right? That's how I abbreviate the angle addition postulate. You add up measure of angle AOC plus the measure of angle 3, that's done by the angle addition postulate, okay? Now, let's see here. Let's get creative. We know that the measure of angle AOC is equal to the measure of angle 1 plus the measure of angle 2, right? Because again, angle 1 plus angle 2 equals the measure of angle AOC. This is also being done by the angle addition postulate. You can absolutely get the same reason a couple times in a proof. That's completely normal. Now, we have a tool at our disposal here. We can finish this proof the next step. You know why? I'm going to tell you why here. So, step 3 will be the final step. It's going to read the measure of angle AOD equals the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Why is that? Well, up here in step 1, we have the measure of angle AOC plus the measure of angle 3. Step 2, we have the measure of angle 1 plus the measure of angle 2 is equal to AOC. Well, if AOC and measure of angle 1 and angle 2 are equal, couldn't we simply substitute the measure of angle 1 plus the measure of angle 2 for the measure of angle AOC? So by the substitution property, we can prove this. This is by the substitution property. So this could have been a one-step proof, but they really weren't going for that. So by the substitution property, we can say that the measure of angle AOD equals the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Now I can tell you, in all proofs, the statement you're trying to prove comes dead last. Most of the time, like 90% of the time, you'll use your given information as your first step. Not always, there are exceptions to that, but most of the time you'll use your given information as your first step. But I do have more examples here. I do got more examples of proofs. Alright, so let's draw a nice line segment here. Alright, so we got line segment FT split into F, L, A, and T. So line segment flat. Alright, so that's our diagram. Here's what we're given. So in this one, we are particularly given that FL equals AT. So we were given that FL is equal to AT. And actually what you can do, if they're equal on your diagram, you can do what's called a congruency marker. Like those one tick marks. Those are called congruency markers. So that might help you on your diagram. What we are tasked to prove is that FA equals LT. Okay, so we were given FL equals AT. We have to prove that FA equals LT. So let's go ahead and start this one again. Let's set up your columns. So let's see, left side's your statements. The right side will be your reasons. Okay, so step 1, in this case I would start with your given information. That FL equals AT. Okay? So FL equals AT. Well, reason 1 is that was given to you. So, and as I said, 90% of the time you'll use your given information as your first step, but it's important to really pay attention to the proof and what they're saying to know whether you shouldn't use it as your first step or not, but most of the time you will. If you let me put it this way. If you're doing a proof and you use the given information as the first step when you shouldn't have, you're just going to run yourself in circles and do a lot more steps than you need to do. Most proofs really shouldn't be more than 5 to 7 steps. If you're getting into 10 and 15 steps for a proof, you're doing way too much. You added way too much information somewhere. Or you went ahead and went in circles. So proof should flow from one step to another. But okay, we have FL equals AT, right? Now step 2, we're going to use LA equals LA. If LA equals LA, reason 2 is that's the reflexive property. And I would abbreviate it like I'm doing here. That's the reflexive property for step 2. Now step 3 is we're going to have FL plus LA equals FA. And then in the same step, you can also say LA plus AT equals LT. So let's see, FL plus LA equals FA. LA plus AT equals LT. Reason 3, that's the segment addition postulate. So we've done this by the segment addition postulate for reason 3. Okay, fourth reason then. So what we got to do now, since we know FL equals AT and LA equals LA, we can totally set FL plus LA equal to LA plus AT. Right? FL plus LA equals LA plus AT. So FL plus LA equals LA plus FT. How can we refer to that? That's going to simply be the addition property. This is done by the addition property for number 4, right? This goes back to similar to what FL would be your A, AT would be your B, LA would be your C on each side, right? LA's equal, FL equals AT, so you can use the addition property of equality to set that up. Now, last one here, we have a 5th step. We can actually now arrive at FA equals LT. We can actually say FA equals LT. How can we say that? Well, for reason 5, let's look at this here, okay? FL plus LA, well, that's equal to FA, right? LA plus AT is equal to LT. If FL plus LA equals LA plus AT, all we have to do is substitute in FA for the first one and LT for the second one. You get FA equals LT. So this would be by the substitution property. So step 5 is true by the substitution property. So we were successfully able to prove that FA equals LT by using the substitution property ultimately. All right. I'd like to do two more. There's two more I'd like to do. Sort of a similar one, but a little bit different in our goal here. So, whoops, these are segments, not full lines. Okay. See, D, O, W, N. Okay, so we have line segment DN split up into D, O, W, and N. Down. We have segment down. Okay, here's what we've been given. So we are given that dW equals ON. We're given that dW equals ON. So we have that information. What we are asked to prove is that DO equals WN. So we were given that dW equals ON. We need to prove that DO equals WN. So let's get started on our proof here. Go ahead, set up your columns. This might be slightly longer. We'll have to see. So let's see. Statements on the left side. Reasons on the right-hand side. Okay, so let's start with our first statement. In this case, let's do the given information. We have dW equals ON. dW equals ON. Reason 1 that was given to us. So that's the first reason. dW equals ON is given. Now, let's see. Step 2, I'm going to do this. I would say DO plus OW equals DW. In the same step, we can say that OW plus WN is equal to ON. So we have step 2, DO plus OW equals DW. OW plus WN equals ON. Right? Okay. Now we have just done, of course, this would be the segment addition postulate. So step 2's reasoning is we just use the segment addition postulate to define these. Now step 3. So from step 2 we have DO plus OW equals DW, and OW plus WN equals ON. Notice from the given, dW equals ON, right? dW and ON are equal. So what we can do by the substitution property is we can set DO plus OW equal to OW plus WN. By the substitution property, we could set DO plus OW equal to OW plus WN. So step 3, you're going to use the substitution property. All right. Now let's see here. Step 4, since these are equal, let's think about this here, right? Well, I'll put a 5th step just for simplicity's sake, but it's obvious that OW equals OW, right? That's the reflexive property. I'm just going to state that here. We have the reflexive property. So step 5, what we can do now, since we have both OWs on each side of the equation, can't we just subtract OW from both sides of the equation? If you subtract OW from both sides of the equation, you're left with DO equals WN. DO equals WN, and we subtracted, so this is going to be by the subtraction property. So it came down to some simple subtraction to prove that DO equals WN by the subtraction property. You see, we use substitution and subtraction in the same proof, so that's why it's important to abbreviate it properly. So yes, we proved that DO does in fact equal WN. So if you want to take notes on this one, I'll give you a second. All right, let's move on to the last one of the day. Let's do the last proof. Let's say all right, so we have, it looks like a triangle here with a line that just keeps on going. We have a triangle. We'll call this triangle KJL. Let's see, let's put the J down lower. This will be angle 4, this will be angle 5, this will be angle 6, right? So we have three angles, angle 4, angle 5, angle 6 in this triangle. What we are given here, they tell us that the measure of angle 4 plus the measure of angle 6 is equal to 180. So we're given that the measure of angle 4 plus the measure of angle 6 equals 180. We have to prove that the measure of angle 5 equals the measure of angle 6. So that's what we're tasked with proving. We're given that the measure of angle 4 plus the measure of angle 6 equals 180. We have to prove that the measure of angle 5 equals the measure of angle 6. So let's go ahead and start with that here. Let's draw our two columns again. Well, let's see here. You have, it looks like what we can start with in this case. In this case, you probably don't want to start with a given first. You probably don't want to do that. There's a very good reason for that. So I would start with the measure of angle 4 plus the measure of angle 5 is equal to 180. All right? So we have here the measure of angle 4 plus the measure of angle 5 equals 180. Where did we come up with that? Where can we come up with that? Well, remember the angle addition part of the postulate, the second part of that? That if you have a straight line and then you have two angles on that straight line, like if a ray intercepts that line, if it intersects it, then the sum of the two angles equals 180. So we can actually say this by the angle addition postulate. So by the angle addition postulate, we can say the measure of angle 4 plus the measure of angle 5 is equal to 180. If you add angle 4 and 5 together, you'll get a 180-degree angle, a straight line. Now, the next thing I would do, this time, I would use your given statement as your second reason. We'll have the measure of angle 4 plus the measure of angle 6 is equal to 180, right? The measure of angle 4 plus the measure of angle 6 equals 180. Reason 2, this was given to you. So that was given to us. Now step 3, I would start out by saying that 180 equals 180. That will obviously be by the reflexive property. So by the reflexive property, 180 equals 180. All right. Well, we have now step 4. Let's think about this a minute. If 180 equals 180, couldn't we substitute in these equations for each side? Couldn't we put in the measure of angle 4 plus the measure of angle 5 equals the measure of angle 4 plus the measure of angle 6? Since 180 equals 180, we can substitute these equations in for each one. So reason 4 will be by the substitution property. And then last but not least, we notice on both sides you have a common measure of angle 4 on both sides of the equation. So we could subtract that out. If you subtract those out on each side, you will in fact get that the measure of angle 5 equals the measure of angle 6, which is what we seek to prove. And this was done by the subtraction property. So by the subtraction property, we were able to prove that the measure of angle 5 equals the measure of angle 6. So that's really how we do geometry proofs. These are the foundational ones. And as you see, today's weren't too bad. I'm not going to lie, there will be some that are a little worse than this, but not always. You can on average expect 5, maybe up to 7 steps. Even though if you get 7 steps a lot of the time, you should question if you have too much unnecessary information in there, or if you're running in circles, because it should flow from one step to another. So there will be plenty more practice of proofs in this course. You'll see plenty more examples. In fact, next lesson we're going to get 2 more theorems. We'll get the midpoint theorem and the angle bisector theorem. We will talk about those. So I hope everybody has a good night. Take care.